Hello बच्चों, today we are going to learn about a very important topic of class 10th, that is balancing of chemical equation. Now, before we start with balancing of chemical equation, let us first understand what is a chemical equation. Here on this slide, you can see a picture of burning coal. Now burning, as you all know, is always a chemical change. So here also a chemical change is taking place, and we know that chemical change, whenever a chemical change takes place, a chemical reaction occurs. Okay. Now if I have to tell about this chemical reaction which is taking place here, I'll say coal is burning in presence of oxygen and forming carbon dioxide with the release of heat and light energy. But this description is quite long. Chemical reaction can be represented in short form in the form of chemical equation. So, chemical reaction in short form can be represented as chemical equation. Okay. And what do we use in chemical equation? We use symbolic notations of formulae of compounds. Okay, formulae of compounds. And what else do we use here? We use symbols of elements. Let's write the chemical equation for burning of coal. It can be written in form of word equation. Okay, let's write the word equation first. Carbon or coal, when it burns in presence of oxygen, okay, it forms, this arrow shows the direction of reaction, forms carbon dioxide gas you can write here gas plus energy is released. Okay, it is in the form of heat and light. This is word equation, and or we can use formulae of compounds and symbols of elements to represent this equation. Now carbon an element, so it is written as C, plus oxygen molecule of element O2 arrow, then carbon dioxide, it's a molecule of compound CO2. It's a gas, so arrow shows direction upward, showing that this is gas, and energy is released. Okay. So what is this? Carbon plus oxygen gives carbon dioxide and energy is released. This is what? This is a chemical equation using symbols and formulae. Okay. So it is easier to understand from the equation. But just seeing this equation, we know what is happening. Okay. No need to describe in long sentences or write complete name. So let's start with the next part, that is balancing of chemical equation. Here you can see I've written one equation. Zinc plus sulfuric acid forms zinc sulfate and hydrogen gas. So here on the left hand side of the arrow, the substances which are written, they are together known as reactants. The substances which are here written on the right side of the arrow, they are known as products. Okay, together known as products. Now let's start with balancing this equation. You can see this equation is a word equation. Now we write the word equation in the using symbol and formula. Now making a chemical equation. Zinc an element, the symbol is Zn. Sulfuric acid is a molecule of compound, so we write as H2SO4. Arrow, the direction of reaction. Zinc sulfate, again molecule of compound, Zn, SO4, and hydrogen gas, H2. Okay. So using the symbols and formulae, we have written the chemical equation. Let's start balancing this. So for balancing this equation, what we need to do is that we need to write the metal, non-metal, oxygen and hydrogen in proper order. So we start with zinc first, okay, below reactant as well as below the products, okay. Sulfur is the non-metal here, hydrogen and oxygen will write later, okay. Oxygen will come then next, and then last is hydrogen, okay. So always follows this order, children. Write metal first, then non-metal, followed by oxygen and hydrogen. Okay, this will make your work easier. Then let's count the number of atom of each element on left hand side and right hand side. Here on the left hand reactant side, zinc, how many atoms of element zinc? 1. On the right hand side also 1. Let's see sulfur. Sulfur is 1. And on the product side also it is 1. How many atoms of element oxygen? 4. How many atoms of element oxygen? 4. How many atoms of element hydrogen? 2. How many atoms of element hydrogen on the product side? 2. Now let's check left hand side and right hand side. We can see left hand side and right hand side, all the atoms of each and every element are equal, okay. So this is a balanced equation. This is a balanced equation and we need not do anything. It is already balanced. Now children, one major question is that why we need to balance any chemical equation. Why can't we leave as such? Why? Because in class 9th you have learned about conservation of mass. Mass of each and every element on the reactant side, okay, mass of each and every element on the reactant side and mass of must be equal to mass of each and every element on the product side. That mass can be made equal by making the number of atoms of each element on left hand side equal to number of atoms of that element on the right hand side equal, okay. So zinc is 1, zinc is 1. So atoms are equal, that is zinc is balanced. Likewise sulfur, oxygen, hydrogen on left hand side, number of atom are equal to number of atom on the right hand side, okay. So this becomes a chemical equation which is already balanced. If it is not, we need to balance because we must follow law of conservation of mass, okay. So now we move to the next question. Why do we need to balance a chemical equation? You have to write this in your notebook and write the answer which I've already told you why we need to, because we have to follow law of conservation of mass. Okay, mass of each and every element on the left hand side of the arrow, that is the reactant side, must be equal to mass of each and every element on the right hand side, that is the product side, both must be equal, okay. And that can be made equal by making the number of atoms equal. Now let us take another example. Here you can see I have written one chemical equation. Carbon plus oxygen gives carbon monoxide. Now you will say that a few slides back, ma'am, you said that carbon, when it burns in oxygen, it forms carbon dioxide. Yes, it forms carbon dioxide. But here this oxygen is in limited supply, okay. When oxygen is in limited supply, okay, or less, then carbon burns in oxygen, in limited supply of oxygen, and forms carbon dioxide, which is a highly poisonous gas, okay. It's fatal. Now this particular topic, the poisonous nature of carbon monoxide, we'll talk in some other class, okay. Right now you just learn that carbon, when it burns in limited supply of oxygen, when oxygen is less in the air, okay, and it reacts to form carbon monoxide instead of forming carbon dioxide. Now let's balance this equation. Is there any metal here? No. On the reactant side as well on the product side, no metal. So we will start with non-metal, that is first one is carbon. Here also we'll write carbon. symbol, okay, and then oxygen, oxygen. We are following the same pattern, non-metal followed by oxygen. Is there any hydrogen? Hydrogen is also not there, so we will not write hydrogen. Now carbon, how many atoms of element carbon? 1. And how many atoms of element carbon on the right hand side? It is 1. Okay, so both sides it's 1. Oxygen, how many atoms of oxygen element? 2. Here 1. Now carbon, you can see it's 1 on both the side, reactant and the product side, so it is already balanced, whereas oxygen is not, so we need to balance oxygen. To balance oxygen, here we will multiply this 1 by 2, we get 2. So with the number which with I have multiplied here, that is 2. This 2 will I'll write in front of, let me use another color, this carbon monoxide. I cannot write it here or anywhere in front of oxygen or as suffix after oxygen. I cannot write. So this is not this is the correct way, since it's a molecule. Okay, a molecule of a compound carbon monoxide, we have to write in front of the molecule. So 2 is here. Now 2, you can see it belongs to carbon as well as oxygen. So obviously the number of atom of carbon also changes. We'll strike off this and write 2 here. Okay. Now you can see, now you'll say, ma'am, carbon is not balanced. Yes, carbon is not balanced, so we need to balance. We can balance it by multiplying by 2, and this 2, where it will go? In front of carbon. And now you can see 2 carbon atom on both the side, 2 oxygen atom on both the side. Law of conservation of mass fulfilled, and the equation is now balanced. So 2 carbon plus O2 gives 2 CO. Okay. Let's move to the next question. This question you all write in your notebook and try to do with me, or you can pause the video, first do it and then tally your work with me. Okay. Those who have not understood yet, they can follow, do along with me. Don't just see, do along with me. Let's start. Magnesium plus H2O gives magnesium hydroxide plus hydrogen gas. Gas, so arrow pointing upward. Let's start. Magnesium is a metal. So we'll write Mg, the symbol. Okay. Then on product side also we'll do the same. Then what we'll write? Is there any non-metal? Non-metal, oxygen and hydrogen are there, but no other. So we'll start with oxygen followed by hydrogen. Okay, similarly here, oxygen and hydrogen. Let's count the number of atom. Now you know, next step is count the number of atom of each element. Magnesium element, how many atoms? 1. Here also 1. Then oxygen, how many atom of oxygen element? 1 on left side and 2 on right side. Why 2? Just a second. 2 on right side because this is in bracket. OH is in bracket and 2 is outside bracket. So 2 belongs to both oxygen and hydrogen. So how many atoms of element oxygen? 2. Hydrogen, how many? Count 2. This hydrogen has 2, okay, plus 2, so it makes 4. So you can see magnesium is balanced, oxygen is not, and hydrogen is not. So we need to balance oxygen and hydrogen. We will start with hydrogen or with oxygen. We will start with oxygen. That is why we have written this order. We are following this order. So we'll start with oxygen, multiply the reactant side on the reactant side with 2, it becomes 2. So this 2, where it will go, you know very well, using another color, we'll write in front of water, H2O, okay, not anywhere else, in front of the molecule. Now this, because we have written this 2 here, so 2 2s are 4. Hydrogen becomes 4, we'll strike off, we'll not multiply, we'll strike off. This also has relevance of this is also there. Why do we strike off? Why can't we multiply? We'll talk about when we do some more equations, okay, where you will understand its importance. So it becomes 4. Now check. Magnesium 1 on both the side, oxygen number of atom 2 on both the side, hydrogen on both the side 4. Is it following law of conservation of mass? Yes. So it is now a balanced equation. Let's see another one. Okay. This is potassium chlorate, KClO3. When heated, okay, this I'm not using any physical state, writing physical state or any other symbol. Right now we are only focusing on the balancing of chemical equation. Later we'll write all rest of the things, okay. So it forms potassium chloride plus oxygen, okay. So we'll start with the metal, that is potassium on both the side, chlorine is the non-metal here, and then oxygen. There is no hydrogen, so we'll not write hydrogen, okay. Count the number of atoms of each element and write, okay, the next step. So potassium is, what happens? Potassium is 1 here, on the product side also 1, chlorine is 1, chlorine atom 1, okay, and oxygen 3 on this side and 2 on the other side, okay, that is the product side. Now let's start balancing the equation. Let's see whether it is balanced or not. We can see it is not balanced. Potassium and chlorine, they are balanced, whereas oxygen is not. So we'll do what? We'll multiply this side with 3. We get 6. Okay, so where this 3 will go? Okay, where this 3 will go? This will go in front of oxygen gas. Okay, oxygen molecule. So we'll write 3 over here. Now 3 2s are 6, fine. Now is the reaction balanced? No, not yet. So we need to balance on oxygen on the other side also. We'll multiply by 2, we get 6. So where this 2 will go? This 2 will go in front of molecule potassium chlorate. Potassium chlorate. Okay, now you can see this 2 makes the number of atom of potassium 2. We'll strike off and write. Chlorine also becomes 2. We'll strike off and write. Okay. Now 2 here. So we need to balance potassium. Potassium can be balanced by multiplying it by 2. It becomes 2. Okay. So this 2 which we have written here multiplied with will come in front of potassium chloride. Okay. This 2 now changes the number of atom of chlorine even. So it becomes 2. Now let's check potassium 2 on both the side, number of atom, chlorine, number of atom of chlorine on both the side 2, oxygen, number of atom of oxygen on both the side 6. So this is now a balanced equation. Okay. Let us now move to the. Now children, I'm going to give you 2 equations for homework. You practice this balancing of chemical equation, revise first and then do these 2 equations. Write your answers in the comment box. I will also write tomorrow the answers in the comment box. Let's see, write down this equation in your notebook. Then the next one which I'm giving you is this one. Manganese dioxide plus hydrochloric acid gives manganese chloride plus water plus chlorine gas. Okay. So try this equation. Okay. So that's all for today. We'll come back with the answer of the 2 equations tomorrow. I'll write in the comment box tomorrow by 12 afternoon. So bye bye for now. Happy learning.